I'm Daniel Hindes with Steinerbooks, and I'm here today with Dr. Lawrence Mathews to talk about Rudolf Steiner's book titled The Light Course, which is published by Steinerbooks and is part of the Foundations of Waldorf Education series. But before we get into the book, let us introduce Dr. Mathews. Dr. Mathews, tell us a little bit about your background.
Well, if I go backwards, I'm currently a science teacher at Shiny Mountain Waldorf School in Boulder. Before that, I taught 2 grade school classes through the 8th grade. And before that, I had a first career as a scientist in biochemistry. So I've been particularly interested in science, the teaching of science, and that is what inspired us today to talk about the Light Course, one of Steiner's science lecture series.
Great. So, turning to the Light Course, what's the background of this book? How did it come to be?
The original name for this set of lectures was the first course in natural science.
Okay.
And it was the first of 3 that Steiner gave. There's the Light Course. Some months later he gave what is now called the Warmth Course, and then some months after that what he did not want to be called the Astronomy Course, but most people today too do call it that. And together they represent a very full summation of Steiner's view on how to teach science. The Light Course, the first one given, is a set of lectures he gave mostly to the teachers in the first Waldorf School in the winter of 1919 to 1920, the first winter of the first Waldorf School in Stuttgart. And the lectures were largely in response to the teachers' questions. They had been engaged in their teaching at this new initiative for a few months, and I believe in all areas, but particularly in science, we're trying to figure out how do we meet the demands that Dr. Steiner was placing on them.
Okay, great. So then in this book we have the lecture Steiner gave to the first teachers about how to teach science, the first version of 3 times he came back to that topic. So tell us a little bit about that. What does that look like in this book?
So in this book he focuses primarily on physics. It's called the Light Course, but he also touches on warmth, on sound, and on electricity, and a little bit on mathematics as well. He was always covering a lot of bases. But in a way, he doesn't say it in this way, but I view it as it's Steiner starting to talk about, 1, how do we teach science, and 2, kind of what's the point of teaching science anyway? What is the goal for the students? And Steiner had several goals in mind there. One would be he had a very critical view of at the time and still today, modern approach to teaching science, a very materialistic approach. And that approach involves saying we have, on the one hand, a subjective observer, and on the other hand, some, in principle, objective perceived phenomenon. And he wanted very much to distinguish to emphasize that that's, in a way, a fallacy, that there is not any objective world out there, that the human being is part of the world out there. And wrapped up in that is the practice of modern science to try and mathematize everything, to bring it to some kind of formula to understand it. And in Steiner's view, there's a place for that, but it can be misleading.
Yeah, well, I'm sure a lot of people would point out that these approaches to science have been highly successful in technology and building the world we live in. So why are they problematic for school-age children, especially before the college level?
Exactly. And that's one of the things I like very much about this book, that I return to it myself. And it's complicated trying to teach what I would regard as the Waldorf education goals of science coming from a traditional science background. And what Steiner does in the very first lecture here is he points us towards Goethe, the German poet, philosopher, and scientist. And of course Goethe himself, despite being renowned as the author of Faust and one of Germany's greatest poets, he regarded his work in the sciences as some of his best work. And Goethe's approach to understanding the world is very different from from the modern scientific approach. Goethe believed very strongly in sticking to the natural phenomena themselves. So he wanted to perceive the facts of the world.
Okay.
And do so in a very deep and comprehensive way. And it is that observation of the facts of the phenomena that Steiner points to again and again in these lectures and in the other science courses and in many other places in the teaching of science when he talked to the teachers about it. The importance of really being able to appreciate phenomena. To be able to look at something and not be going, as we tend to do today, to look for the cause behind it, to look for some unknown. Goethe always wanted to stick very much to the known.
And so a lot of times students, if you show them something, a flame, they'll say, "Oh, fire!" Right? So what's wrong with teaching them 1,001 labels for the way things, quote unquote, are? Right.
Yeah. There's not necessarily anything wrong in that, but it's incomplete. And it has certainly been my experience teaching both grade school children and high school students that it is very complicated for them in today's world to see what's in front of them. And thinking here about the primary content of this set of lectures, the light course, light itself is a very mysterious and in a way hard to know thing. We experience it every day, and yet we don't necessarily look. So if we go from our common experience and we shine a light on something and say, "What do you see?" Then the student will say, "I see a red ball."
Right.
But then when you try and go into something more about it, then many students who have explored Google and
they'll just jump in and say,
the
"Well,
modern world.
But Dr. Mathews, don't you know light is a particle and a wave?"
Light is a particle and a wave, and it's bouncing off of the red ball, and it's bouncing into our eyes, and we're seeing that. And it's a very profound question. Do we see light? Or even more basic, what is it that we see? And in the Waldorf School, of course, we introduce physics for the first time in the 6th grade, and then teach it 6th, 7th, and 8th, and every year in the high school. And optics, the study of light, is part of 6th, 7th, and 8th grade. And then we leave it aside until the 12th grade and come back to it again. And I find these lectures helpful in a way at all of those stages, because you want to be building up for the students a greater and greater complex and rich view of the world. And in today's world, we want them to appreciate what does that mean that they might pair it originally. Light is both a particle and a wave. How do we come to know that? But before they can engage in that in a fruitful way, need to be able to see what's there, and need to be able to have, in a way, a more phenomenal, based in the phenomena, appreciation of how they can observe things that are being illuminated.
So as an example, your red ball demonstration, if you were to dim the lights in the room, the ball wouldn't be so bright red anymore. It might become dark red.
Classic experiment that I like to do, first experiment in optics in the 6th grade, go into a completely dark room, and then very, very, very slowly raise the level of illumination and see what you observe. And for those that haven't done that, it's a fabulous experiment. Even better to go outside on a really dark night, away from city lights, and observe a sunrise. And of course, things change color and depth, and your perception of them is very different. I like to do that experiment again in the 12th grade, and then talk more about the physiology of the eye and how we see things and how those changes come about, and really explore them further. So that's a very nice one for that.
So people might be tempted to say, well, that's all nice and good, but why I'll put it in the most unkind frame. Why bother to waste your time on that when there's quote unquote real stuff to learn?
When there's real stuff to learn, yes, and that points back at this initial question, kind of what is the goal of teaching science?
Mm-hmm.
And some of our students go on and they pursue careers in science. Most of them do not, as most students at any school do not. And yet we have every student study physics,
Mm-hmm.
grades 6 through 12, and it's not to train them to be physicists. It's to help train them to be full human beings in a way. That in learning to observe phenomena carefully, to discuss them objectively,
Mm-hmm.
without resorting to causes behind or forces that we can't see, but just to really be able to pursue this Goethean line of investigation in which he would go from phenomenon to phenomenon. And I'll give an example in a moment from Goethe. One of the classic ways to think about the practice of science today is, on the one hand, a system of classifying things, right? Grouping things together. Second, to be looking for causes for things.
Mm-hmm.
What are the forces behind this? And coming from that to some kind of natural law. So explaining things through lawful behavior, repeatable behavior. And Goethe, for all of those, had really a different approach. He's looking not so much to classify things, but as to observe a phenomenon very carefully, to observe another one carefully, and then to see how do the phenomena metamorphose or transform from one to give you this.
Mm-hmm.
So here is a classic example that is introduced in 8th grade, primarily in an observational way, and we try and come back to in the 12th grade and understand more fully. And that is this distinction between Newton's view of light and Goethe's. So of course one of Newton's classic experiments is to place a prism, a triangular prism, in a beam of light and show that on the wall you get a projection of rainbow colors, from which he concludes that the white light contained all of the other colors in some way. And if any student is to say something when that experiment comes around, those set of observations come around, they will know that. Well, the prism breaks the light up into the other colors. It's all there in the light. So Goethe knew about this this experiment, and in the late 1700s, early 1800s, prisms weren't so abundant as they might be today, and he borrowed one from a local dignitary, borrowed a set of optical instruments, and then put them on the shelf and was doing other things, and the messenger came from the count or the duke, I can't recall which it was, saying, I'd like my instruments back. And Goethe said, wait, I haven't done the experiment yet. And so he picks up a prism and he looks at the white wall on which a light was shining, expecting to see the rainbow, because that's what Newton said, is that the prism would break up white light into its constituent colors. And all he saw was the white wall, except at a place where there was a smudge on the wall, a dark spot, and at the dark spot he saw fringes of colors. And he said, I can't send the prism back yet, I have more work to do. And so he spends a long time investigating light and color, and has a whole book called his Color Theory. And what he finds is that for the prism to generate distinct colors to our eye, you need to have a light-dark boundary. So if you imagine an experiment in which you shine on the wall a circular beam of light, and then you put a prism in the beam, two things will happen. One, the spot on the wall or the screen will be displaced a little bit, and you'll get a fringe of color top and bottom. The top fringe will be blue-green, and the bottom fringe will be yellow and red. And we do similar experiments to that, both in the 8th grade and the 12th grade, and try and have the students observe carefully enough that they come to the realization there's no green in that image. Of course, green is the central color to the rainbow. And so here's an example of how do the phenomena metamorphose.
Okay.
So now imagine that you have a hole in a screen through which you're shining a beam of light, and now you make the hole smaller. And now the displaced spot of light on the screen is smaller, the fringes are closer together, you make the spot small enough, and the fringes now overlap, so the yellow and the blue that were at the inner edges of the fringes overlap, and now you have green created. Why did Newton see green, see the full rainbow spectrum when he did his experiment? And that's something that we explore in the 12th grade. How is it that Goethe's view, from which he said Newton is wrong, is different from Newton's view?
Right. It's a bold claim, challenging Newton on.
It's a bold claim.
Light.
It's a bold claim, and I would say that no modern physicist brooks it, right? That they discard what Goethe had to say, and yet in that practice, we believe pretty strongly that there's this great value in really looking at what you see, and of course what you see in some situations is not a full rainbow spectrum. You don't get the light broken up into all these different colors. You see something different. It's not to discount Newton, and it's nice if there's time in the 12th grade to come and talk about, well, here's another understanding of color, that we have electromagnetic radiation, different wavelengths, we perceive that in different ways, they react with different materials like the glass prism in different ways, and in the end, if you can have the students understand that and appreciate Goethe's poetic claim that color is the deeds and sufferings of light, that you get color by the interaction of light and dark, that then you have a very rich understanding of the world. And you have exercised your observational and thinking muscles.
Muscles, indeed. So on a practical level then, are teachers, say beginning teachers who read this book, are they going to find like a step-by-step how to set up an experiment and what to do in what grade? Is that the type of thing found in here?
That you will not find in these lecture courses. These, for me, are lectures that, on the one hand, they will point you to other places for that kind of practical information. Especially for the optics and some of these kinds of physics experiments that require fairly simple instrumentation or equipment. There are quite a number of resources available today to get that. What it does is it gives you Steiner's direct view on Goethe's thinking, which other people have written about, but one of Steiner's activities as a young man was to edit Goethe's writings, his scientific writings, so he was very familiar with that approach. And then the other component to these lectures that you don't get in a how-to manual is Steiner's comments on how we perceive the world with different elements of our being. So he speaks in here about the ways in which we might use the etheric, or we might use the astral to be perceiving light or to be perceiving sound in different ways.
Okay.
And those are very. There's no answer for me. There's no answers in there.
Okay.
It's hypotheses about how it is that we understand the world, how it is that we understand the human being.
Things to ponder for decades.
They are things to ponder. Yeah, you come back and I have certainly had the experience that I reread some of these books and I find a question mark from last year or 10 years ago, or when I first read it 15 years ago. And now the question mark is it might turn into just being crossed out, it might become an exclamation point.
Mhm.
It might acquire a second question mark.
Right, right. Well, these are the kind of dense, rich, thought-provoking types of texts that we have come to
Mhm.
appreciate from Steiner.
Mm-hmm.